It stands for Julia, and then the PY, right, stands for obviously for Python. It stands for Python, and then the TER, the TER stands for stands for others. Right? So by others, we mean other programming languages. For example, C++, Java, R, etc. Right? So Jupyter stands for Julia, Python, and others. So everything is appropriately named. Right? Pandas stands for Python for data analysis. So Julia is a programming language similar to R. And then obviously, you know, Python, then others, obviously, some of you might be ahead of languages like C++, Java, and so on. And then NumPy, NumPy or NumPy, something NumPy or NumPy, it simply stands for numerical or Python. Right, so it simply stands for numerical Python. Right. So everything is appropriately named. So Pandas, Jupyter, NumPy, and so on. So everything is appropriately named, right? So that you know, right? If we go back to now the library. So here we've got and now we import the libraries. We import NumPy, we import Pandas, we import matplotlib, and then we run the cell. So this is so in terms of I don't know if you covered this in your Jupyter programming. So in your programming, whether you covered what Jupyter notebooks are in detail. So you'll be required to be able to apply them when you're doing your machine learning projects. So this is called a cell. Did you cover this, guys, at all? When you're doing your programming, guys, did you cover Jupyter notebooks, what they are?
Yes, we did the basics. Like how to run your cell, markdown, headings, and so forth. We did the basics.
Yeah. Okay. All right. Yeah, all right. Then, so if you did the best, so you know that this is a cell, and then this is a markdown, and you change this how the cell behaves by changing the attributes of the cell here, right? So if it's markdown, it means it's simple text, and with the markdown, this means it's a header, right, and so on. Right? So if you did that, then that's fine. So let's go into Pandas. So Pandas is a Python package that deals mainly with what we call with two types of data. So it deals with one-dimensional data, two-dimensional data, and three-dimensional data. So a one-dimensional data is called a series. A two-dimensional data is called a data frame, and then a three-dimensional data is called a panel. So those are the three main types of data structures that it deals with. So a Pandas series is a one-dimensional labeled array containing data of some type. So the data's structure can have integers, which simply means numbers, strings, floating point numbers, meaning numbers with decimal points, and then you can also have Python objects. So the axis labels are often referred to as an index. So for example, if we wanted to define, if we wanted to create a Pandom series with random data, right, with 5 random data, we use this function from NumPy called a random number. And then what this will give us is it will give us 5 random numbers, right? And all pandas, whether it's a data series, a data frame, or a panel, they all are labeled with the starting index is always 0, right? So we start off from 0, 1, 2, 3, and 4 because we've got 5 objects, right? So and these are the numbers that have been generated within that pandas series, right? So if we want to find the index values of the series, we say S1. So here we've labeled our series and we called it X1. So we say X1.index. We print that, and then it will give us the subposition is 0, and the stop is 5, and we're doing one step at a time iteratively. So it means we're starting at 0, then 1, then 2, then 3, and then 4, right? So that's what this will give us. So it will give us our starting index and our ending index and our incremental values of the index. So we're incrementing it by 1. So 0, 1, 2, 3, and 4 means we're taking one step at a time, right? Is that clear?
Very clear.
Yes, sir.
Following John.
Yeah, and then when you creating you can also your index doesn't have to be numeric, right? What Pandas allows you to do, it allows you to create non-numeric indexes. So for example, we can create since we've got 5 random numbers, we can create an index, and the first index you can call it A, and then second B, and the third C, the fourth D, and the last one E. And then if we print that, you'll see it will now give us the indexes as A, B, C, D, and E, right? And then if we then say S2.index, for us to view the values of the index, it will then show us that these are our indexes, and our indexes are no longer numeric. They are now of type of string or object. Therefore, if we want to access the first element of the index for our series, we then say S2, and then we put that in square brackets, and then it's A, and then it gives us this value, which is this one, right? And what Pandas does in this instance, if I do this, so you can see my whiteboard, yes?
Yes, sir.
Yeah.
Yes, sir.
Yeah. So what Pandas allows you to do, all right? Right, can you see this? So this. So this are the user defined indexes that we've defined. So what Pandas allows you then to do is for you to define if you've got user defined indexes, Pandas will always maintain a numeric index even if you've got a user defined index. So how Pandas does that, it has got what it calls lock, which stands for index location. So this is index location 0. This is 1. This is 2. This is 3, and this is 4. So Pandas will always maintain a numeric index for you, even though you can have a user-defined index that you've created. So if we go back here, you'll see that this is the a non-numeric index that we've created by defining inside the series for the series here. But if I then want to access the numeric index, I can then say s2.iloc for index location 0. So it should give me the same value. Right? You see here it gives me the same value. So what that tells you is Pandas maintains a numeric index even though you've got a defined index, your own user-defined index. Is this clear? Hello, is this clear, guys?
Clear.
Yes, sir.
Yes.
Yeah. So sorry, I missed that. Yeah, so you can also do this. I can also say print. Is this what you're saying? It'll give me the same result. Yeah. Yeah. Is that clear? Here I can also do and it should give me the same answer. Yeah. Is this clear? Yeah. Okay. So if we so for example, we can also create a series from a dictionary, right? So you remember from your programming course that a dictionary is a data structure that contains key value pairs, right? So it contains key value pairs. So this is the key, this is the value. This is the key, this is the value. So it is a dictionary is a data structure which contains key value pairs. So, right, so here if I print it, and then I can then create a pandas series out of the dictionary. So this is the dictionary from the print data, and then this is the print of the values pi of the series, right? So we've just created a pandas a series from a data dictionary, from a dictionary. And then if you want to index, if you want to print, so the series is indexed by the key values, right? So we index by the key values, right? By the defined. So S3 pi is also the same as print right? Which will give, it gives us the same result. And remember, we said with pandas, the index location is always numeric, right? Even though you've got a user-defined index, in this case, it's the key value of the dictionary, right? But pandas always maintains a numeric index through ilog, which is the index location. So this should give us the same. So this should be index 0, and this is index 1. So if we then say S3 ilog 0, it should give us the same value, which is the same as saying print S3 ilog 0, right? And then we can also create, so in this case, we're creating a big a dictionary, right? That we've created with five values, and if we look at it, it's still the same. This is still the first element of the series. Oh, and also, well, what you can do with pandas, remember we defined our dictionary here that we call the data here, which has got pi and e, right? Right. So in this case, we can reorder our index by creating another index, and we say e, it becomes the first element, pi becomes the second element, and then if we define another index, let's just call it tau in this instance, you'll see e now is now the first element, pi is now the second, and then tau, since our data dictionary did not have a key value called tau, it now gives us not a number. So what that actually means is that there's a missing a value for that key value pair. Right? Is this clear?
Yes, sir.
Sorry,
Yes.
may you come again on tau, how the missing value pair?
So remember, this data is our dictionary, which is here, right? It's got two values. It's got pi and e. E for exponential value, right? It's got two, isn't it? Yes?
Yes.
Right? And what I've just done here is I'm reordering the elements, right? So I want pi to be number 2, and I want e to be number 1. So then I'm just showing you that you can, if you then add an extra index which is not defined within this data structure, it will return a not a number or a null value, right? Is this clear? Yeah. So I can simply do this, right? Remove the tau so that you see, right? So what is just showing you that you can reorder the values.
Oh, okay.
Yeah.
That's fine, thanks.
So a NaN or NaN is specifically used in Python and Pandas, meaning it's not a number, or meaning there's a specific value missing in Pandas. Right. So you can also create a Panda series from a single number, right? So you can say, I want to create 10 values of a single number 1. So then I'll say index is equal to range. So range will give me up to 10, right? And then we can run it, and then you see it will give me 10 values, so 0 up to 9, and each element is all ones. So you can create a series from a single number, and this is how you do it. Mufaro, can you please mute your mic? Mufaro, can you please mute your mic? Mufaro, Madisha, can you please mute your mic?
Okay.
All right, thank you. All right. Going back, so you see we can create a Panda series from a single number. What else did I want? Yeah, and then if we talked about printing, which was a question, and then also with Pandas, if we wanted to, remember this is the string S1, which was series, which contained five numbers, 0 up to 4, which were this one. So if you wanted to access the first 2 elements, right? And what we do is we say S1, and then here we can either put a 0 or leave it blank, and then we then specify. Can you see my cursor?
Yes.
Yes.
So S1, S1 is our Panda series, right? And then we then use square brackets to access what's inside that particular a series, right? So if we then say we use a bracket like this to then we put 2, and then we want to access the first 2 elements. We can either put a 0 here, which is, so this is the starting position of the series, and this is our upper bound. By upper bound, it means that it goes up to, it won't exceed 2. So this means this is equivalent to say, get the elements of S less the index less than 2, but it starts at greater or equal to 0. So this is what it actually means, right? So it means, so what that means is that 2 is the upper bound, right? 2 is the upper bound, and then the starting position is 0. So this will then return, so if we say S1 and then semicolon 2, what that would then give us is, you see, it returns 0 and 1. So this is the same as saying, as we said, 0 is always the start, so we don't need to mention 0 because 0 is always the, so you see these two are the same, they give us the same result. Yeah, that's clear, yes?
Yes.
Yes.
Yeah, and then S13 means it will the first 3 elements, right? So this will give us 0, 1, 2, and remember 3 is the upper bound. And this is the same as saying, but we don't specify the starting position to be a 0, right? Yeah? Yeah. And then S13 simply means start at with index 1 up to 3, and remember 3 is the upper bound, so it should give me index 1 and 2 only, right? Yeah, you see, and it gives me index 1 and 2. Remember, 3 is the upper bound, so it will not exceed 3, right? So which is, so therefore it returns 1 and 2. Yeah, that's clear, yes? And then you can also use a negative indices. By negative indices, we mean return all values, right? That's what, sorry, we return all values from, so we've got 0 to 4, isn't it? Right? So it means return all values 0 to 4 except the last one. Yeah? Are we together on that one?
Yes, sir.
Yeah, so the minus 1 simply means give me 0 to, so instead of doing this, right? So instead of saying this, right? Sorry, 4. So instead of saying this, right? You see, instead of saying this, right? I want to just use one value to, I just want to use one value that will give me, that will return all of these values and leave out one, right? Which is the last one, right? So in this instance, I just say I use a negative index to show that I'm leaving out one, and that the one that I'm leaving out is always the last one. Is that clear?
Yes.
Yes. 4 is the last one, right? So remember, it's indexed from 0 to 4. So 4 is the is the last one. Sorry, can you say that again? I missed what you said. Oh, okay. So let's so, yeah, yeah. So you see, here I've got what the -1, so that you understand what does the -1 actually mean, right? Let me come back here, right? So so remember, this is the starting position, right? If you remember here, we said this is the what? This is the starting position, isn't it? And this is the ending position. So in this case, right? So if we've got, right, and then we've got this, and then a -1 here. So what that simply means, select all the data in the series and leave the last one out, right? Yes? So here it means we're starting from position 0 and we're leaving the last one out. Yes? That is clear, yes? Yeah? Yeah, you're following, right?
Mm.
Yeah? You're following, right? This is the starting and this is the ending, right? So we're saying leave the ending position out. Yeah? Is that clear? That's what the -1 said. So, but if we then do it the reverse order to say this, right? And then we say the -1 is here, right? Right? Can you see that? Right? So what is that? So if it says, if this one says select all and then leave the last one out, right? This one is actually saying leave all and select the last one. So, all right. So that you get it, right? So this one is select all and leave the last value out, right? Yeah. Yeah. And then this one means, right? Means leave out all values except the last one. You get it? Yeah? It's exactly the opposite. Do you get it? Yeah. Yeah. So what this will do then is this one will give me all the values from 0. Isn't our index is up to is 0, 1, 2, 3, and 4, right? So this one will give me 0, 1, 2, and 3, right? And leave out 4. Yes? And then this one will leave out 0, 1, 2, and 3, it will leave them out and just give me 4, the 4th element. You get it? Yeah. So that's the difference, right? Based on this on the indexes. So this one is the starting element, the ending element, right? Starting at 0, but if we say -1 means leave everything out and give me the last value only. So if we go back, you'll see if I say this one, if I specify here, it gives me the 4th element. Yes? Yeah. Yeah. So sometimes your series is so big, right? And you want to select the last value. How you do that is by doing this. Yeah. Right. And sometimes I want to select. So let's say you're doing a regression. You guys did regression. So you know regression, you've got a dependent variable and an independent variable. And if I want to then run my model and select my dependent variable and independent variable, so it means I'll then do it, I will use something like this for that selection process. Yeah. Where my single value, which is my independent variable, is I'll do this, right? Which could be the last one value out of the elements, right? And then select my my dependent variables with this. Yeah, is that clear? Yeah, is that clear, guys?
It's clear.
Yes, it's clear.
Okay, so this will select 0 to, so this will give us 0, 1, 2, 3. So if I wanted to select elements in out of order, so this one will, I then use a double brackets. Can you see it like this? So what this simply means is give me the 3rd element, the 1st element, and the 1st element. So basically, I'm just selecting the order that I want. So I'm getting the 2nd, I'm getting the 3rd, right? Because I'm starting at 0. So 0, 1, 2, then 2b is the 3rd. Right? Then the 2nd element, and then the 1st element. Based also in this instance, I use 2 square brackets and then a comma to separate the ordering that I want. Yeah. Right, and then this is just selecting pi, and then a dir simply gives me all of the functions that I can run on S4, right? So all of the on the data series, right, that I can run, right? So S4 dir means it gives me all the it's a listing of all the functions that I can do on the series, right? So you find I've got a function here called median, right? And you find median is come on, is somewhere in this list. Where is it? Yeah. Okay. So if you're not sure what especially if you're in an exam, you're not sure what functions you can actually do this. You can run this function. Then it will just give you a list of all the functions, right? Is that clear?
Yeah.
Yes,
yeah.
sir.
So yeah. So if now I want the median, right? I can say print median. Then I can say s4.median. It will give me the median of the values, or I can just say s4 median, right? And then if I say s4 describe will give you all of the statistical functions that you can do, right? So it will give me the count, the mean, the standard deviation, the minimum, the 25 percentile, 50 percentile, 75 percentile, and the maximum value. So that's what describe will do, right? It will give me a summary of this statistics, right? So if I want to then say S1 greater than 0, right? If I want to say S1 greater than 0, what that simply means is I want to all my values which are greater than 0. So how you do that is you specify S1, which is my series, and then I specify the criteria that I want to see. So in this case, I want to see all the values in the series that are greater than 0. So and then specify, I want to see all the values in the series greater than 0, right? And then this is what it will then show me, right? Then the same is I want to see all the values in the series which are less than 0. And this is what it will give me. Yeah. Then I want to see, for example, all the values of S4 which are greater than the median, right? And this is what it will give me, right? Yeah, is this clear?
Yes, it's clear.
Right. And then NP. So what I can do is I can also get I want the exponential values of my series. So I can and then say so this function is found in the NumPy in the numeric Python. And then if I run that, it will then give me the exponential values of the different elements, values that we saw earlier. And then I also can create an array which is dynamically aligned, right? So if I want to say which one which is on which the index value and the value are aligned, right? So I can do this by using a range, a 6, and we will see later where that is useful. So I can define with the range, right? Right. So let's right. So let's do an exercise. For example, you create a series of your choice and exploit, right? And then you run s1.head and s1.dtype to be able to look at some of the attributes and methods that are in Pandas. So for example, dtype will give you the data type values in the series. Empty returns true if it is empty, right? So for example, I can do this. I can say s1 dot dtype, and then it will give me what the data types are, that it is of type float, or I can also do no, I can't. Dtype, and then it will give me that it's of type float. Then I can also say S1 empty. This is a Boolean, so it should give me false. That is not empty values in the right. And then size will give me the number of size of the series, that is it's got 0 to 4, which means it's of size 5. And then I can say S1 dot head like this, and then it will give me all the values. Yes, yeah, here in this it will give me all the values. And if I say S1 dot head, and if I specify 2 here, it will give me only 2 values, the first 2 values, right? And then if I say a tail, S1 dot tail, it will give me the last values, right, of the series. In this case, if I say 2, it will give me the last two values, right? So you've got a head and a tail. Tail gives you the last values. Head gives you the first values. Yeah, is that clear? Right? Yeah. So now what we expect you to do is to just create your own series, and then you do head and run the same functions to be able to do D type, empty, size, values, head, and tail. Yeah. Yes, guys, you got. Now it's 14:06, so I give you until this is just 5 minutes, right? 5 minutes, or until quarter past. No, quarter past is too far. Until, yeah. So I give you very short 9 minutes. Quarter past, and we'll see what you guys have done. Then we'll move on to the data frame. Is it clear so far?
Yes, sir.
Yeah, so you've got 9 minutes, guys. Quarter past, let's see what you guys would have done.
Yes, sir.
No.
Yeah, so now we've done the series, which is a one-dimensional structure. So a data frame is a pandas data frame is a two-dimensional structure, right? Which has got rows and columns, similar to an Excel spreadsheet. Yeah, so if we define a dictionary, so if we define a dictionary, and then we say that dictionary has got a series of Alice, Bob, and Chris and their ages. So what this will give us is it will give us a two-dimensional structure with name, age, then say Alice is 21, Bob is 25, and Chris is 23. And then if we do a head, it will give us, so head gives you the first 10 elements, because here we've got less than 10 to retain everything, right? Right, and what you can do is you can also add, so if you've got a structure which is a two-dimensional structure, like a spreadsheet, you can also add columns, right? So if we then say, let's add a column called height, right? And then we then add the height of the, then you now have name, age, and height. So Alice is 21, is 5.2, and so on, right? Yeah, this is clear, yes? So a pandas data frame is a two-dimensional data structure, which is defined by rows and columns. So normally most data, right, is defined in 2 dimensions, rows and columns. So let's, in this instance, import our data called salaries, right? So we then say in this instance I say PD. So we've got a function that reads various types of files. In this instance, I'm reading a CSV file. So in this instance, I say pd.read CSV file. Then I name the CSV file, which is in my the same directory as my Jupyter notebook. And if I run it, right, and then I say .head, it will then give me the same. It will give me the first 10 values, right? So I can remove this 10. You'll see it will give me the same. Oh yeah, it's the first 5. Sorry, head is the first 5, not the first 10. So if I say 10, it will give me the first 10, right? The first 5. And then if I say tail, it will give me the last 5. It will give me the last 5 values. There you go. It will give me the 1, 2, 3, 4, 5, the last 5 values. So head gives me the first 5, tail gives me the last 5. And what Pandas also allows you to do is the data doesn't have to exist in your local directory. It can even exist on the web as long as you've got the URL. So this is the URL of where this data is found, right? So I can then pull that data. Why is it giving me an error? Oh, it's no longer, the data was removed. Sorry. The data the file was removed for some reasons anyway. So let me remove that. Yeah. Right. Let me remove it because the file was actually so in this instance. So let me then do this because I was supposed to demonstrate. So you can actually then do this. Say df is equal to. We're supposed to show you that within this, I can even specify a location where the URL of the file is on the web, and it will put it. All right. So this is the same. It gives me the first 10 values, and or 20 will give me the first 20. Tail will give me the last 5 records. Yeah. Then if I say type df, it will identify the type of data frame it is. So tell me it's a Pandas data frame. And then if I want for a single column like salary, it will tell me what it is, right? Then it will tell me sometime. So if I want for everything, and then say df.dtypes, right? Then it will tell me what it is. So another way to do it is to use info. As I said, df.info. Yeah. And then df.info, what it will do, it will tell me what type of data it is, right? To say rank is of type object, discipline is of type object, and there are no noun values in it, right? And then salary is of type int 64, and then it will tell me the memory and that it's using that. I've got 3 integers and 3 objects as part of my data structure, right? So it actually tells you the column, right, and the data type of each, which is similar to this, but this info gives you more information in terms of that it also tells you whether there are now values or not. Is that clear?
Yes, sir.
Yes, sir.
Right. So we're all running. Yes, we've managed to run. So df.columns will give me what are the columns. Yeah, the columns are rank, discipline, and PhD, service, sex, and salary. Yeah, so these are the columns. So, and if I say df.axis, it will give me the starting position and the ending position, and then it increment the data is stepped 1 at a time, and then it will then give me the names of the columns, right? So that's what axis. So axis is similar to df.columns, but the difference is it doesn't show you columns doesn't show you the range index. So that's the difference. And then if I say any dim is number of dimensions, so number of dimensions is 2 because this is a 2-dimensional structure. df.size will give me what is the size in terms of the memory that it occupies. df.shape. So df.shape will give me the what is the shape? It's a 2-dimensional shape which has got 78 rows and 6 columns. Right? Is that clear?
Yes, sir.
And then the size, which is 486, is defined by 6 multiplied by 78. Is that clear?
Yes, clear, bro.
Yes, clear.
Yeah. And then df.describe, remember we said describe will give us all the summary statistics, and then it will tell me for PhD what is the count, for service, for salary, what is the mean standard deviation, 25% or 50%, or what is the maximum value for each one. Yeah. And df.mean will give me the mean of each column value. So it will give me for PhD service and salary that are numeric. So Tapio, if you recall, you had some values in your dictionary which were not numeric, and therefore when you ran the dot describe, it only did the summary of the numeric value. So it's the same for mean. So in this instance, we've got rank, discipline, right, which are non-numeric, and therefore it will only then give us for PhD, service, and salary as for the mean for those 3 columns because they're numeric. Everything else, non-numeric, it will not give us. Yeah, that's clear, yes.
Yeah, clear.
So as an exercise, if we wanted to calculate the standard deviation, we'll then say df dot standard st distance for standard deviation, and then to give us for only the numeric value. Then if you wanted to calculate the average of the first 50 rows, what we then do is we then use df.head 50, then it will give us the first 50 rows, right? Then we can then say Chimuti mean, right? Then it will give me the mean of the first 50 rows of data, right? Yeah, is this clear?
Yes.
So the thing that I gave you has got all the examples filled in already. So I actually gave you the answer sheet, so ish. Yeah, anyway. Okay, all right. So if we wanted to calculate the statistics for only the 1 column, we can say salary.describe, and it will give us the count, the mean, the standard deviation for that particular column. Okay, all right. Going back to the lecture. So if we then want to do for each column, we then just select the column, and then they specify the type of summary that we want. If you want the count, if you want the mean. All right, so now let's talk about grouping data, right? So for example, we can group data using a particular column. So if we say the function to do that is group by. So if we want to group data by rank, we can then say df the group by rank. And we can then say, let's see what that data looks like. So you can see all of this data is grouped by rank, right? It is grouped by this particular column called rank. Then we can then actually then say what is the mean of the ranked data. Then you will see that it will then tell us that for the associate professor, for only the numeric column, which is PhD services salary, this is the mean, right? Or I can take a particular column which is numeric and find the mean. So that I can then say df dot group by, which is the gender, and then it will then say gender, right, which is sex, then female, male. Then it will give me the mean for those two values, which are female and male, to give me the mean of PhD service and the salary, right? So I can also calculate the mean of salary for men and women. So if I do this, right, it will give me if you see the difference between these two. The difference is I've selected a column called salary. And this is I want everything. This is the only one salary. Then it will give me the gender, male and female, and it will just return only the specific column that I want, right? And then if we use double brackets, right, the difference is that it will return a pandas data frame instead of a one-dimensional frame. You see, in this instance, the difference is now I've got gender, male and female, and this average, the mean salary. And with this one, I don't have it like in table format. This one is just a one-dimensional structure. This is a two-dimensional structure. So when you specify double square brackets, it means you want the it to return a pandas data frame. And then I can then do, for example, if I can select two columns. If I want to rank to group by rank and gender, I can then do this to say group by rank and gender, and I want you to sort the values, and then I want you to return a data frame of the mean of the salary. So this will look like this. It will look like rank, right, which is associate professor. What's the female and the male? Associate assistant professor, female or male, and then the professor, female and male, and for all of them, it gives me the salary, the mean of the salary. And if you see the difference, remember we said with the square brackets, double square brackets, if I do this, it will only give me something that doesn't have a one-dimensional structure instead of a two-dimensional structure. You see the difference? This is a 2D structure. This is This is actually a table, and this isn't a table. It's just output. And so that's the difference of including square bracket, the double square brackets. At the end, it gives me a two-dimensional structure. Is this clear?
Yes.
Yes, sir.
Yes, I've got a question,
Yes.
Doc. I just wanted to check what is the difference between group by and sorting for some reasons or the other. When we first introduced the data frame being grouped by rank, I was expecting associate prof to start, but unfortunately started with prof. I thought it was going to sort it probably by alphabetical order or something. So what is the difference there? Thank you.
Well, the difference, let's remove the, and then you'll see, right? So can you see what is doing? So you're asking what the sort, yeah?
Not that sort, but that sorting where we choose in ascending or descending order. So when we introduced the group by, I was expecting it to group probably starting with in alphabetical order or something. So I just wanted to know what is the difference between grouping by and sorting in alphabetical order or something.
Okay. So group by, what group by function does, it will group all the data according to the rank and the gender. In this instance, is this clear? That it will group all the data, can you see, according to the rank and the gender, right? And then it will then sort the rank and the gender alphabetically, right? So in this case, associate professor, right, is sorted in alphabetical order, right? We first have associate professor, assistant professor, then professor. So this is alphabetically correct, yeah? But this is the the descending order, right? And then we've got female and then male. That's also alphabetically correct. This is the descending order. And then we've got female and male for assistant professor. Or this becomes correct. So what this means is it's sorting the rank and gender, right, in alphabetical order. So what that means is it's grouping all the data according to the gender and rank, and then sorting that data, right, and giving us the mean salary for those, right? Yes. Do you get it?
Yes, I got it.
All right.
Thank you.
So for example, if you wanted to group the data by discipline, we can also say group by discipline, and then specify the salary. So the discipline is either A or B, and then it then gives us the mean of the salary. So we can also do filtering, right? By filtering, we are selecting the observation within a certain range of values. So, for example, if we wanted to create a data frame where only the salary is greater than 120,000, we can then do this, and then it gives us a data frame where the salary here is greater than 120,000 because we specified this condition. And then remember, axis will give us the index of of these. So we've got 0, 3, 5, and 7. And you see 0, 3, 5, and 7, right? And then it gives us the index of the. So it gives us the index of the rows, right? 0, 3, 5, and so on, right? It gives us the index of the rows. Because remember here it gives us the first 5, but this is all the index values, right? So we can select data for where the gender is equal to female only, right? So we use a double equal to mean that it's we want where gender is equal to female. So the double equal means that we want it's not to assign, but we want it to be equal to female. So what that does is it only gives us gender female for that particular a data frame. So for example, if we want to filter the data where we want the discipline is equal to A, and then the salary is and get the mean salary of it. So we can actually then specify to say we want column discipline, we want it to be equal to A, right? And then we want the mean of that salary for that particular discipline, where it's only equal to A, right? And then it will give me right? And then it will give me the value, yeah? And then for example, yes?
I just want an explanation why we put BF outside the square bracket and then BF discipline.
Well, so sorry, you're saying you want what outside the square bracket? What do you mean?
Like we have BF, like on line 96.
Oh, okay. So the explanation is, so this is the criteria that we were looking for, isn't it? Yeah?
Yes, I understand. But the reason why we have BF at first and then we have the other BF discipline inside the first square bracket.
This one.
Yes.
Yeah, remember this this is the condition, right? For basically what we're saying with what's inside the bracket is we're saying the condition that we're trying to filter, right? So this is the filter condition, and this is the data structure that we're using for the filter condition. And this, in this case, our data frame is DF, right?
Yes.
Yeah. And then our filter condition is this, right? So from every column called discipline, we only want A.
So
Yeah.
maybe we could have used a for loop, but it has been compressed into the syntax. Or maybe an if statement, it has been compressed into this. The if statement has been compressed into that syntax.
Yeah. So sorry, you're saying why did we use a for?
No, I meant maybe if we say if this is equal to female.
Well, what is equal to female? Sorry.
Okay, if we say if the contents of the column is equal to A. Okay, I was just asking on the clarity of the syntax only. It's okay, we can move on. We can move on, sir.
That is okay. So what we're saying, this is the filter condition. And remember, the filter condition is not programmatic. You can only specify, you can't say if this, then that, right? You can only specify the condition only. And then to figure out that this is what exactly you mean.
Okay.
Because it's not programmatic, you just specify the filter condition. And then it gives you this.
Okay.
Right? Yeah, is that does that answer your question?
Yeah, it does.
Yeah. So if we wanted to do like complicated things, for example, if you wanted to filter observations with a salary greater than 100,000 and find how many female and male professors in each group, we can actually then say, specify the condition that we want it to be 100,000. Then we want to group it by a rank and gender, right? And we want to sort out that. And then we want the salary count. So what this will do is it will give us this, right? It will give us salary, right? Count, and then which is greater than 100,000. And then for each gender, what it is. So if you look at this expression, and then we can, you will see, for example, that you can combine multiple expressions, right? So we can first do the filtering, and then we can group the filtering, and then we can then add another filter where we say we want the count. So it allows you to chain multiple expressions. Is that clear? So if you look at your assignment, these are some of the things that they were asking for. Yeah. If you now go in retrospect, if you now go to your assignment, then you can see that this is what they're asking for. So can we take a 5-minute break, and then we'll move on to plotting, slicing, and dicing of Pandas data frames. Is that okay?
Okay, sir.
Yes, Doc.
Yes, thank you.
Yeah, all right, let's take a 10-minute break.
Are we following what has been happening since morning, or is there anyone who is lost? Or probably we are just speaking to ourselves. I see a few people are participating here. Anyone who's having difficulties, trouble in what has been covered so far? I'm talking to myself. Are we there?
Yes.
GTJ is there.
Yes, we are.
Yes, so far.
Dr. Jones is there. The rest are hiding, or they are not even on their screens. NS is there.
I'm here.
I prefer it to be more lively than it is right now. If you're going to enjoy what you're doing, we don't want to make it a misery, isn't it? Do you agree with me?
Yes.
Okay, because this is supposed to be enjoyable, because you already use spreadsheets, I'm sure, all of you. We've never used a spreadsheet. Something that's happening with the sound.
It's giving feedback, sir.
Okay. It could be the speaker. Okay. So if you have any problem, please just raise your hand and say, I don't understand this, or I don't understand that. I think we are all adults there. then we may be able to help. Because by the time we get to the assignments, we don't want copying assignments without you actually knowing what's behind it. And the projects, of course. We want you to understand what you're doing from the ground up. Yeah? Don, you can proceed if you're ready.
Yes, sir.
Yeah, okay. Don, you can proceed.
Okay, so we were here on more on slicing the data set, right?
Yes, precisely.
Okay. That said, okay, on this one, you remember that time when we importing stuff? Control. Much better. You remember that time when we were importing libraries at the top, we imported matplotlib.pyplot as PLT. So it's a plotting library which we use for drawing plots. So that library, it's sort of inbuilt into Pandas. So you can draw directly from a Pandas series without a Pandas series or a Pandas data frame without necessarily calling the plt.plot function. So this is what we're doing. In this, we're slicing only one column of the data frame. Oh, there are two different notations for achieving this. One, we can say df.salary, or as you were doing before. So these are the columns. In this instance, we extracted this salary column and plotted it. So it would have been the same even if we had said df salary dot plot.
Sorry, sir. Can you enlarge your screen? I can hardly see.
Okay. Is this better?
Much better now.
Okay, good. So I was saying, this using df.salary is the same as calling the salary column like this. Just a different syntax for achieving the same result. As you can see, the plots are identical. So you can choose one or the other. Are we together on that one? Then when we now say df.plot, in this instance, we're not slicing anything. We're plotting all the numeric columns in df. So when you call this plot function, it will plot PhD salary service. However, due to the high ranges, the wide range between the values of the other columns and salary, these will just be presented by a straight line. However, in the event we were to remove salary, service and salary, yeah, this will be the same thing. So as Doc said, when I'm calling a column, I use this single, if I use the single square bracket, what is produced is a Pandas series. See? Dot salary. What we produce from this is a series. It's a Pandas series, right? So a series, as Doc said, it's just a one-dimensional array. However, sometimes when we're slicing, we would want to pull more than one column. So what then is produced would be a data frame, the two-dimensional array. For instance, in this case. So we put our square brackets, then inside those square brackets, for choosing what we want, we put a list of the items we want to extract. In this case, we want salary and we want service. Can we see? So what happens here is, if you make a mistake of putting only one, it will throw an error. You see? So for it to work, you have to put these two arguments in a single list so that it will be a single argument. Let's assume it's so this ability of pandas to just plot directly, it's actually very, very, very convenient, because to produce something of this sort using just matplotlib, it will be a few more lines of code rather than just the single line and plotting directly from pandas. So yeah, this we have looked at. It's a series, yes. So here it produces the first 5 rows of a series or a data frame. So even if you select a single column, but if you put this double square brackets, what is produced is a data frame. Case in point, df2 is equals to this. So if we are to look at df2, we'll see that df2 is a data frame. To look at the type, despite the fact that we selected a single column. So if we put this double square bracket, what's produced is a data frame. We put a single square bracket, what's produced is a Pandas series. Are we together on that? So another thing you may want to know, since I'm talking about the plot, the various plots you can apply. Plot automatically pulls.
I think there's someone who's drowning. Simon Mutaki. Are you okay now? He was failing to run something. He said he's not okay. What's your issue? Hand it over to Don. He will sort it out. Simon, can you grab the screen so that Don can see what you are having on your screen? Don, can you give him the...
Okay. Yeah. I can see from what he posted. Right. The challenge is, okay, let me try. Stop presenting. Okay. Share your screen, Simon. That way I'm sure everyone will pick up. Hello, Simon, can you hear me?
Hello.
Hello.
I say I'm trying to share my screen.
Okay.
Should I choose my entire screen or window?
You can or a tab.
A tab.
Oh yeah, if you are using Jupyter Notebook on the same yes, I was saying Jupyter Notebook on the same browser you are using the Google Meet.
Okay, I'm able to see.
So the challenge is that file is no longer available on the link. So you now have to use the file you downloaded from the Google Classroom.
Okay.
So scroll to that line of code you have.
Yeah. It's this one.
You didn't run the cell where you say my data. You didn't run that cell. That's why it's blank. It doesn't have a cell number there. You need to run it. You need to start from the right at the top of the of your file of your workbook or your notebook. I think you just jumped to my data. It doesn't know what salaries it is because you haven't run the
copy that code.
Yeah, you need to run that.
Okay.
Do you know how to run a cell? You click on run at the top there, or you can do the control something.
Okay.
Yeah, I've tried to run it. That's
okay. Can you go right at the top of your notebook and start running everything? See, maybe you didn't.
Mr. Proud.
From the beginning.
Yeah, from the beginning, the first one at the top.
Okay.
Yeah, start running from there.
Simon, can you hear me?
Yes, I can hear you.
Okay. Your challenge, it's not running everything per se. What you need to do is this. If the file is no longer... Can someone mute their mic, please? I'm getting too much feedback here. Since the file is no longer available on the link, we're using the local file. And where we get the local file, it's on, where is it? Control F. Yeah. I'm trying to find where I ran it. Okay, this was the series S1. Okay, good. You see, I commented this out, this section. So you can change the name on my data to DF, or you can copy this you can copy this cell pd.read salary CSV and you paste it here. Control V. So it should look like this now. DF equals to PT. Instead of DF is equals to, since the file is no longer available at that link, use the local salaries file. You download it from Google Classroom. Do that and everything will be clear.
All right, thanks. Let me try.
Okay, advise if it works.
All right, that's fine.
It would definitely work.
All right, thank you.
Okay, yeah. So I'll wait for you to just run everything, and when you're caught up, I'll continue.
Hello.
Hi, are you caught up?
Yeah, I'm caught up again.
Okay, that's good.
Yeah, you can proceed. I say you can proceed.
Okay, noted. So where were we? Right. Filtering, more on slicing the data set. Right. DF1 equals to salary. We check the type, we saw it's a series. DF2 is equals to DF salary. We checked the type again. Because we use this double square brackets, the type is now a data frame. And as we were saying, there are various plots you can plot with pandas. So in this instance, we're just doing a line plot. We're just doing a normal line plot. Then if we are to specify kind here, it will give us a bar graph. For instance, where is it? Oh yeah. Nice. Okay, let me look at the sex column. It's categorical. So if I'm like df dot sex dot lot kind equals to df dot, since it's not numeric, I'll just make it numeric by first counting how many elements exist in each. So you see, you can plot a bar graph with pandas. You can plot a line plot. You can even do a pie chart. So it's very versatile. Hi. Yeah. With okay, a numeric one. Okay. Okay, we had done that. This is how a service plot would look like. The one we had done initially, dot plot. Since it's a continuous variable, if I am to try and do a bar graph of each, it won't come out nicely, I think. You see? So unless I specify the kind, the default kind is a line plot. So I just wanted to just, while at it, show you how you can plot a categorical column using the same function, the same notation. However, okay, I do understand the way I did it made it look hard, right? So if we say df.sex, we're just selecting the single column, right? Are we together on that? So there is a pandas function called value counts. It will then count how many males are there in here, how many females are there in here, and return the outcome as a pandas series. Value counts like this. Can you see this? So what I will now be plotting is this series. 39 males and 39 females. Plot. Since I do not want it to be a line plot, I will then specify the kind. Equals to a bar. Or you can even say a kind equals to pi. Then you can draw a pie chart. So was it a bit more understandable this time?
Yes, thank you.
Okay, you're welcome. So if we say DF2, remember DF2 is our salary data frame, right? Which we code salary here, right? That's DF2. So we're drawing a DF2 histogram of the salary column. This is how the salary values are distributed. If we say df.hist, it will draw all the histograms of the numeric. It will draw all the histogram of the numeric columns in the data set. So the numeric columns are PhD, salary, and service. This is how they are distributed. So my bad. df.hist. So a cheat code I'm going to show you when you're using a Jupyter notebook. If you put your cursor inside a parenthesis like this, then you type Shift Tab. It will show you the arguments which enter into that particular function. If you come here and you press this plus, it will even go down and start explaining what each argument means. And what you can enter into each argument. So this works for all the functions. Syntax.
Please say, may you come again on that one?
If you put a cursor inside the parenthesis like this, right? Then you press Shift and Tab. You come here, expand, you get all the arguments, you see? In df.hist, in the hist argument, there is a column argument, there is a by, there is a grid, x rot, ax, etc. Share x, fixed size. For instance, okay, df.hist, oh yeah, I'll use the fixed size argument for you. Fixed size is equals to, so if you are typing something and you press tab, it should autocomplete or give you suggestions. See? So how would I have known that we have fixed size in here? Shift tab, you find here it is fixed size. How will I know what arguments fixed size accepts? There we go. It accepts a tuple or a tuple, size in inches of the figure. So the tuple contains x and y, row and column, length and width, whatever you would like to call it. Now, if I do it this way, can you now see the size of the plot has changed? Are we together so far?
Yeah, thanks, Doc.
Yes.
Not yet a Doc. Shaitar. So this is a box plot of the various columns of the numeric columns, how they're distributed. And you know how to interpret a box plot, right?
No, sir. Can you assist?
No, I don't.
Okay, 25 percentile, the median, the 75 percentile. I think this is the 99 percentile if I'm not mistaken. And this is an outlier. So anything above this in this line would be an outlier. So it gives you how your values are distributed. You see, so you now know that your salaries, you know, they range from a little over 50,000 up to, a little over 150,000. However, the majority of the people are in the around 80 to 125,000 range. We have a few who are in that other range. So that's how you interpret your box plot. So you remember that time when I was talking about the kind argument, you are now seeing it here. So we are now plotting EF, but however, this time we're plotting a density plot. We do not want a line plot. And when we say subplot equals to true, it should plot different plots for each and gives us a layout. 3 by 3, 3 rows, 3 columns. Can you see the outcome? So, some of you may be wondering what the Sherek's argument is. Long story short, you are telling it whether to also plot non-numeric items. Kind, scatter, grid, where is it? Position. Fixed size tuple. Oh yeah, on kind, you see, line plot defaults, you can choose a bar. Bar edge for horizontal bar plot, yeast for histogram, box for box plot, KDE for kernel density plot, pi scatter hex bin. So Sherex, they did not document it in here. However, if you set it to true, it will attempt to print even the categorical variables. So
sorry, it's
here
under
in
the
this
subplot.
Subplot, okay.
Yeah, just below the subplot.
Yes,
if you go back where you were, where we have the kind of bars.
Okay. Well, we have the kind.
Yes, the kind of bars. Then if you scroll down a little, then you see Sherek.
Read style. Log xt crowd font size. Table mark backend.
Just below where you were talking about the kind of bars that you can plot.
Okay, here on kind, right?
Yeah, if you scroll down.
Fixed size using title.
It's different from mine. Because it says Sherex.
Okay, yeah. Oh yeah, I'm guessing it's here. column by share X false. There we go. In this case, subplot equals to true, false. It will alter all the x's. It will set some axis labels to invisible. Oh, yeah. So basically, that's how it's like your snippet of the documentation of any function you're using. So you remember when I was telling you about outliers. So as you be constructing or developing your machine learning models, outliers tend to have an adverse effect on your model. So these are good things to know and be able to plot.
Sorry, sir?
I'm saying as we will proceed, go further and you start developing your machine learning models, you realize that outliers have an adverse effect on model performance. So, the ability to identify them is actually vital or crucial. So that you normalize and you deal with them accordingly. IDF2. Now, so now we're going into sort of like advanced slicing, but this you have already done. Right. So can you see this? DF go up to 10.
Sorry, sir, before kindly explain to my subplots, to my layout, to my share X, to my fixers. What do they mean?
Subplots, title. You remember in this instance, we just said df.boxplot. And you are not printer everything in one plot. That's why my boxplot is here. Not my figure, salara kakura, e ukumadiki. Make sense? But not subplot equals to true. Now saying print each numeric column in a different plot. Each man for himself, or each plot for itself, in this case. Layout. Layout is how do we want it to appear? Okay, I'll play around with this. Okay, 3 rows, 2 columns. In this instance, can you see the difference now? The first figure refers to the rows per plot yangu. The second figure refers to my columns and aripo. That's what layout is. So I can have a 3x3 layout where I have 3 rows, 3 columns, or 3x2. That's what layout is. Then setting share X to true. What I've realized it does is it tries to plot categorical variables, tries to squeeze them in, and in so doing it could alter the axis of your plot. So by default, it's always set to false. If you notice, then fixed size. This one we went through it. It alters the size of your plot.
Okay, I get it now. Thank you.
Okay. So when you're slicing like this, using this, it's rows, comma, columns. If I do not specify a particular thing, it will mean I'm taking everything. So here I'm specifying only the rows I want. And kindly note, when you're using an index location, note that if we're using a range from 0 to 10, remember the upper value is not included. It's not inclusive. So from index 0 up to index 10, it means it will not include 10. Inochipa kusvika pana 9. Are you realizing this? So if we're index location, however, if you are using a lock argument, lock kind of includes that lock, the upper limit is inclusive. Can you see in this instance? $10 to $20. 20 will double up. 0 to 10. 10 will double up. So when you're choosing the slicing method you're going to use, take note of these nuances. But sometimes unenguchida include kana washansa lock, not the upper limit will be included. So if you are writing your code, make sure the syntax will reflect kuti urikuperera paukuda. When you're using iLock, the upper limit is not included. So by default, I go like a value, one value higher than the limit. Because here, if I wanted up to 10, I would put 11. You see? Can you see? Like I said, up to 10. Up to 9. So is this making sense to you?
Yes, sir.
Okay. So this is the lock function 10 to 20. You see? Salary sub DF sub equals to head 50. And where did we define our DF sub? df.ilock. Makes sense. I was wondering why upper we picked up to 20 and it did not include 20. It's because the sub that frame height or in at 20. 19 it goes up to 26. So that should not confuse you. iLock. So in this instance, lock inoenda tracker where this label is equal to 10. Tracker with up to the point where this label is equal to 20. or the figure just below that, kana 20 isimu. All right? iLog haina basa nezvakanyorwa uku. It uses the index. This is labeled 26, but it's at index 10. You understand? Since this is a mumbo-jumboed index. This is labeled 45, but it's at index 19. That's how iLog works. So that's another nuance you have to take note of. If you're using these two, they do the same things, but they work differently. Are there any questions on slicing? So no questions would mean I covered most like data frame slicing adequately. Is that correct?
Hello, sir.
Hello, yes.
I think on the iLog there, yes. Maybe you may you come again on the iLog, where we say df sub iLog. If you are saying 10:20, does it mean that row from row 10 to row 20? Then on the rank, on the column headings, I think I've seen it, but now on this one now I'm seeing 0, 3, 4, and 5. May you kindly assist by explaining those ones? I think they are a little bit confusing me a little bit.
Okay, now df sub, right, was created using this. This is how we developed df sub. It was a filter. So it only returned rows where salary was greater than 120,000. Are we together? Regardless of Kuti, this thing was on index 4, was on index 5, etc. And only, that's why you see the index here. It's not set. Right. df sub dot tail. You see? Upper index 72. But if we say df sub dot shape, it only has 25 rows. So what it was doing, what this filter was doing, when a salary was greater than 120,000, it would place it here. Isiri, it will leave it. So 0 was greater, 1 was not, 2 was not, 3 was greater, etc. So we found 25 such rows, but it did not alter the index. So df contains the index of the elements in the original data frame, not index yao mo data frame the df sub. Are we together on that?
Yeah, on this one now, I think I'm now starting catching up.
Okay. So when we now came here, when we were doing log, since this index is no longer the index of this item, data frame, it's the index of this row in the original data set. So this index is now a mere label. You understand? It's no longer an index, it's just a label. Not chinenge row 26, but row 26 is number 3. You understand where I'm coming from? So 26 is just a label. It does not reflect the index position. So when we say log, df.log, 10 up to 20. It chooses everything with the label 10 up to the label 20, right? When we say .ilog 10 up to 20, goes per position 10 up to position 19. As I said, the upper limit is not inclusive, regardless of the label. Am I now making sense?
Okay, so it means the ILOC actually uses the natural indexing, which appears despite the fact it's not written, but we know that the indexing starts from 0, 1, 2. That's the one which uses ILOC. While its log uses the index in the main data frame originally assigned the label, which is now like a label like.
Yes, log uses a label. ILOC uses the index position. If you catch it like that, you're good to go.
That one is the first part, which is on the rows. Now we are having 10, 20. That one I am now understanding it on ILOC, comma. We now go to the 0, 3, 4, and 5. What I do now, I was expecting to see a service, sex, or salary.
ILOC looks at, so it's DF sub. Good. Oh, ILOC looks at index position. So now we're looking at columns. This is 0. This is 1. This is 2. This is 3. This is 4. This is 5. Saga 0, which is rank. 3, meaning 0, 1, 2. 3, which is service. 4 and 5, sex and salary. Index position, index location, not label.
Thank you very much. I think now I understand the difference between log and ILOC. Thank you very much.
So can I just ask there whilst you are still there?
Okay.
Just confirm something. When we create the DF sub,
yes,
yeah, move inotora malabel ayabva nayo ku DF, but pama
yes.
index, but my index inototangidza kuti 0, 1, 2, 3.
Yes, index, despite what's written, pazviri, index per background will always be 0, 1, 2.
It's okay, it's okay.
Pana rank up. What is displayed is rank, but the index position is what? 0.
Okay. It's okay. Thank you.
Okay. So we're good to go. Now we are looking at sorting data. So we see DF sorted equals to sort values by service. So when we write sort, the default argument is ascending equals to true, meaning start with the smallest and end with the biggest. You see, this is the default argument. Shift table here a number good sign. So they did not even have to specify it. But you only go to see that's what's going on. So, regardless of the index label, we're going to sort area item. Where service, the smallest service was 0. So it's not sorted according to service, not according to those original index labels. Now, when we say sort values ascending equals to false, meaning we're now sorting in descending order. So it starts with the largest surface, followed by starts with the highest value up to the lowest. So that's the syntax of sort. Now, you remember Pesepata Kishanda would always assign a new variable name to whatever it is we're working on. We filter, then we assign the name to df sub. Then Pamsoro up, we sorted the values and assigned the name to df sorted. Right? However, there is an argument called in place equals to. By default, this argument is set to false. By default, this argument is set to false. So when you put it as true, it means it makes those changes in the original data frame. If I do not specify with in place equals to true, it just returns a copy, which is not and the changes are not saved in memory. So the copy shows me what the data frame would look like with changes. Right. How can I sort? Good. So in place equals to true, it overwrites the original data set. df.sort values by service ascending equals to false. In place equals to false. So what in place equals to false means is I'm making a change here, but this change is not permanent. It will not be saved, such that when I then do this, we won't see a difference because the change was effected here. Let's ascending equals to true. So you're seeing I'm now changing what this data frame is looking like. I'm trying to make it now begin with the lowest service value up to the highest. So in ascending order, lowest first. However, since in place is equals to false, nothing changes. Are you now getting what I'm saying?
Sorry, sir. Your comment on in place is go to false. Is that the right comment?
Yeah. Yes, it was deliberate. I was leaving it. I was trying to show that if in place is equals to false, nothing changes.
Okay.
However, if I comment this out, can you see? It returns this copy. However, this copy is not saved. Because when I now code the data frame, so that's how in place equals to true and in place equals to false work. Sisonke. Tritese.
Yebo.
Okay, nice. Now we're restoring the values. So you see, when we sorted by this, the index got mixed up. So if we're restoring to original order, we now sort index instead of sort values. Then in place equals to true. Voila, we have our original data. So there we go. Now you have an exercise which you have to complete. Sort the data frame by salary in descending order and display the first few records of the output, the head. How long would you need to do this? Three minutes, 2 minutes, 30 seconds, 60 seconds, 45 seconds. Cannot do better. Better. Okay, can anyone share and show me their solution? Zvinofatsa kana vana chidai. Oh yeah, I'm noticing a message from Spiwe about iLog. Did you finally get it, Spiwe? Sorry, I couldn't snap for up my chats.
Yeah, it was an odd message. Yeah, it was for the time you were hitting the iLog for the first time. So when you come again, yeah, I got something.
Yep, that's good. Anyone to present their solution on sorting the data frame by salary? Hi guys. All right, ndongo nunga chero iri.
Nonga ichero.
Okay. Simon, regatuona ati tiri tese zvemashuwa ere. Hello, Simon.
Can I try, sir?
Yes, go ahead.
Is that right? I see my screen.
Yes, Tapio, we can see it.
Is that right, Ishmael?
I'm not sure, but I'm noticing that your 155.8. I'm noticing that the data is sorted by what? By salary. Yes. But I've got a different code. I just exchanged like Tapiwa's code. On ascending, I said, it's the same, false and true. It's okay. Yes.
Okay. Yeah, and yes, the output, that's the correct solution.
But I wanted to check, Don, why is it descending is not working?
No, it is working. He sorted by salary. The first value is around 186, followed by 162, 161.
No, I'm saying instead of writing ascending, I used the opposite of ascending and I said descending.
And what happened?
It told me that let me check the error. It said it got an unexpected keyword argument descending.
Exactly. It means that descending is not part of the keyword arguments. It's not part of the arguments expected by the sort function. So,
okay.
When you press Shift Tab, you will see a list of all the arguments a certain function expects. And when you expand, you can now see what those arguments accept as an input. So descending is not an argument, and ascending is the only argument there. So you now have to choose whether it's ascending, which is ascending equals to true, or descending, whereby you're saying not ascending, or ascending equals to false. So that's good.
Sorry, sir. Is it possible with the data run sort according to the way you want it, but presentation you have a different? Because my columns are looking a little different from Tapiwa's.
Okay. Share your screen.
Okay. I hope I can do that. Let me see. Let's go. So I want to share. Is it showing?
Nothing from my end yet. I don't know. Can the others see his screen?
Let's go.
Not from my end. Not from.
Not yet.
It's not showing.
Yeah,
Scan out.
Was it seems like his salary was the last column, but my salary is right in the middle. So I'm not sure if I got something wrong or.
No, scroll up a bit. Okay. Can you see that item sort index x equals to 1? Yes. Sorted the what you call it, the columns, sort of like in alphabetical order. Now scroll down.
Okay.
So you see, it maintained that order.
Oh, okay, I get it.
Can you also see what I've done? Okay. Can you see my screen?
Oh, yes, it's visible.
Okay, this is what I did. I created another DF name, DF underscore sort by this one. And then to be honest, I copied this. And then I put the This one. Then I ran it. So this one was just a contingent in case it didn't work. So it didn't work when I ran this one, but it worked when I ran this one.
Okay, yeah.
I thought I would need to. Yeah, I thought I would need to.
Sort values by salary. Okay. Dot sort index equals to 1. Okay. Right. On your second row, what you were now sorting are the columns. So you are now sorting your columns in descending order.
Oh.
You were sorting columns in descending order.
For the one that I've highlighted here, this one.
The df dot sort index equals to
this one
equals to false. Or to yes.
Okay.
X is equals to, it says we are sorting by columns. The default is X is equals to 0, which means we are applying this particular function or item to the rows. 1 is to the columns. Then sort by equals to sort values by salary. Which is
the results came out.
Yeah, which is kind of strange because you are now supposed to say on the sort by, you were supposed to specify that it should be in descending order.
Where? Here?
Yes. On after the by salary, by equals to salary, you say inside, yes.
Outside the bracket.
Inside the bracket.
Here.
Yes, comma. Yes. Ascending equals to false.
Like this.
Then uncomment df dot sort by, then run the cell.
Like this.
Yeah, then no, the bottom cell, uncomment the bottom cell.
Which bottom cell? This one.
The last.
Oh, this one.
Exactly. Now run that.
Okay. Yeah, Buddha. Oh, okay. So this is the other way of doing it.
Yes.
Okay.
Put you to a variable etc.
Oh, all right. Thank you.
All right. Now, okay, I have to share my screen again. A tab. DF. Many ways of killing a cat, right?
So it's okay not to put sort by inside the bracket of the values. Like
okay. In this instance, the first argument is by. So by default, whatever I put the first time, it associates it with by. How can I put this? If my first argument was going to be ascending, I'll have to specify could ascend. However, if I'm putting my arguments in this order, I don't even have to specify could by axis etc. For instance, it's by axis then ascending. For example, I can do it this way. By 0, false. I'm not going to assign those arguments in that order. But you know our experience that is not assign the wrong argument to the wrong value to the wrong argument. But it's another way of doing it. Now, when you go there, so is the flight CSV still available? This guy, let me check. Not found. Man. Okay. I'm trying to source the CSV, then we'll proceed. Thought I had it somewhere in my machine. Hi. Oh yeah, I just wanted to finish this notebook. Ango Sarapadik. Then I will finish up. So I'm just looking for the flights data set, and we should be good to go.
Don? Hello, class. I can see there's there's a need to stop like now, but if you take it that way, there's a lot of ground to cover up to the end of your course. The basics. I don't know how strong your introductory courses were when you did Python. I think you also did data visualization, isn't it? Or we are all gone?
No, we are here.
We are here.
Still there. Yeah, I can see some are saying the law of the diminishing returns. We are not getting anything. But you only started around 10, isn't it?
Yeah, that's true.
Yeah, and if you are going to take advantage of this training and get your Python up to scratch, I think we have to cover a lot more ground than you had covered before. Do you agree with me?
Yeah, we do agree.
Yes.
Are you learning anything new from what we have heard since morning? Because you could have actually have covered much of that ground and been comfortable already in the Python course. Am I right?
Yeah, we are getting and we're actually understanding things much better.
Much better, isn't it? So it had always been the case with those who came before you, so that we get productive when you now get into machine learning. We take it that you now know the level that is expected out of you. You got the background. That's why we are trying to do this. Otherwise, we could just quickly get into machine learning and more than half of you will be lost and then we won't make real progress, isn't it?
I do understand where you're coming from, sir. And seeing as some want to go, those that want to go, they are free to leave. Seeing as the lecture is being recorded, they can follow through the recording later.
Okay. When you see when you get onto YouTube, it's different from what you're getting here. When someone is lost, we try and ensure that that person gets on board as quickly as possible. You notice it, isn't it? Playing back YouTube would, yeah. Okay, we now have about 60. We started with 80 plus. I noticed we are now less, much less.
Yes, I also appreciate what you say. What may assist is just to have a day pre-plan where we are supporting more. You prepare psychologically and other preparations that needs to be done. I'm not arguing about the benefits. I fully appreciate that. Maybe for today we can finish that way you are planning, and maybe for tomorrow we can have it pre-planned to say, let's start from 8 until 4 o'clock, and I hope also.
What was the protocol? What did you agree with at the beginning at 10? What was the end time?
There was no agreed end time.
Okay. So if that was not set, I was informed that it should be 5.
No, it's fine. I think this was just for discussion because we are not far away from 5 minutes.
Okay.
It's trying to let those that want to go. I also believe that the purpose why you're putting this effort, try and get as many of us, up to speed.
Okay, good.
Okay, thank you.
Don, are you done?
Unfortunately, is a challenge. The flights,
if the data is no longer there, it's okay. We can always stop if there's nothing else in the workbook. coming, isn't it?
Yes, I think upload the data is 500 megabytes, so it will take a while.
That will take forever. So we might as well stop now, and they can download it overnight, and then tomorrow it will be ready.
Yes.
Are we agreed? I'm asking the class.
Yeah, that's fine.
Yes, sir.
We are all agreed, isn't it?
Yes, amen.
Okay, the other
Yes.
guys before you, they will always answer in unison. You don't seem to be comfortable. Why? I have a big yes. We are all agreed, and we are happy to go. And but before you leave, I want to make it sure that you should go and revise everything you have covered since morning. Because when you come back tomorrow, whatever we did today, it's assumed you know it.
Okay.
Where you may have been lacking, since you are not asking questions, make it sure that you try and get it. If you don't, and then you should raise the questions tomorrow first thing in the morning that I couldn't get this or I couldn't get that. The other way of doing it is to just send any one of the instructors a quick message that I'm having trouble here. We don't want any one of you to be lost. We want this to be productive to both yourselves and ourselves. We are agreed?
Yes, sir.
Who's got an issue there?
Maybe when you started talking, our network was misbehaving. So we wanted to ask what time we are going to start tomorrow.
It has to be by agreement. For those who have already left, we're at 85. What time will you start? I thought you had made the protocol first thing in the morning when you started. What time did you start today?
Today we started at 10.
At 8?
10.